So here we are solving two-step equations day 2. In this lesson we will use tape diagrams to help solve two-step equations. Part A, select all the expressions that are equivalent to 7 times 2 minus 3n. So I'm going to look at this like I'm using the distributive property. I'm going to multiply 7 times 2 to get 14. Then I'm going to multiply 7 times a negative 3n. 7 times negative 3 is a negative 21n. So do I have that there? 14 minus 21n. That's C. But our job was to select all the expressions, so the ones that are equivalent to this. Well, 9 minus 10n, that's definitely not it. 14 minus 3n, that would be an improper use of the distributive property. But having on part D here, this 7 on the opposite side, it's still 7 times 2 is 14. It just looks different. And then 7 times a negative 3n is still negative 21n. So D is also a correct option. And E looks something similar, but it doesn't have, it's 7 times 2 is 14 times negative 3n is actually a negative 42n. So that is not one. It is C and D, and that's just use of the distributive property. Part B, write an equation to match each equation and solve for the unknown variable. So basically we're taking a tape diagram and converting it to an equation and then solving for the variable. So I'm going to read these left to right. We have 5 and 2x's. That whole thing is equal to 19. So I can write it like this. 5 plus 2x equals 19. And now we're going to reason our way about the diagram to help solve this, how we show it algebraically. So I have 5. In order to figure out what those x's are, I'm going to take 5 from 19 to see what's left over. So I'm going to subtract 5 from each side. If it helps you, sometimes it's a good idea to put a dashed line or a light line right down your equal sign because we're solving an equation. And what we do to one side, we have to do to the other. 5 minus 5, that's a 0 pair, so that cancels to nothing, or 0. Drop down the positive 2x. I don't have to write the plus. All I have to do is put the 2x. It's implied that it's positive. 19 minus 5 is equal to 14. And so this portion here is now equal to 14. And I'm going to split that 2 ways to figure out what 1x is. So I'm going to divide by 2. I draw a division bar down below here. 2 divided by 2 is simply 1, or just the x, equals 14 over 2, 7. So in this case, 5 plus 7, that all adds up to 19. So remember, we're just using that diagram as a way to solve our equation and help ourselves out, figure out what are the algorithmic steps to write down when we solve it. Let's go ahead and look at B. Here I've got 2 and 1, 2, 3, 4, 5 x's, so I can write 2 plus 5x equals 19. And I want to let you know you also could have wrote it this way. You could have put the 5x's first, 5x plus 2 equals 19. All right, so we're going to go ahead and solve each one of these. It means the same thing because addition is commutative, so it doesn't matter which one I put first. I'm going to first do the one on the left here. 2 plus 5x equals 19. In order to figure out what x is, I'm first going to take away 2 from 19. So subtract 2 from each side. Again, if it helps, put a dashed line down the middle. Put your bar. 5x is left over. The 2's cancel. Equals 19 minus 2 is 17. Now they purposely do this to understand we're not going to have a whole number as an answer here. So we divide by 5. We're dividing that 17 that's left over here 5 different ways. The 5's cancel to 1. I'm just left with the x equals 17 fifths. That's the same thing as 3 and 2 fifths. You can leave it as 17 fifths or 3 and 2 fifths. Either way, it's the same thing. It's the procedure that's important. Now I'm going to go ahead and do this again this different way here, just the way it looks. We have 5x plus 2, but the process is still the same. We subtract 2 from each side, and we get 5x equal to 17, and then we divide by 5 to get the x all by itself, because it's the opposite of multiplying by 5. So we get x is equal to 3 and 2 fifths. Part C. If I notice part C and D, how they differ from A and B, is that we have groupings of x plus 5 and x plus 2. So our equations are going to look different. Here's C. We have x plus 5, x plus 5. So I have two groups of x plus 5. I'm going to write down 2 parentheses x plus 5 equals 19. So the first thing I'm going to do to find x is I'm going to split this 19 two ways because I have two boxes. So in other words, I'm dividing by 2. So the way I show my equation, I divide by 2 on each side. Again, draw your dashed line if it helps you. And 19 divided by 2 is going to be a decimal answer, actually. So 19 divided by 2, you can think about it, goes in. 9 times 2 is 18. Still left with 1. Put a decimal. I'm trying to do this all by hand to show where it comes from. And 2 goes into 10 5 times. So each one of these boxes is worth 9.5. So I'm just going to write down now the x plus 5. I don't need to write the parentheses anymore because the 2 is gone. So I have x plus 5 equals 9.5. Now my last step is to subtract 5 from each side to figure out what x is. So I put minus 5 here and minus 5 there. 5 minus 5 is 0. Write down my x equals 9.5 minus 5 is 4.5. So we had two groupings of x plus 5. Let's take that same idea and move it over to part D. We have x plus 2, 1, 2, 3, 4, 5 times, or 5 quantity x plus 2 equals 19. In this case, I've got 5 groups of x plus 2 that equals 19. So I'm going to take that 19 and divide it 5 ways. I show it by dividing by 5 on each side. I get x plus 2 equals 19 over 5. Well, that's going to be a decimal or fraction. I'm going to keep it as a decimal. So 19 divided by 5, that's 3.8. So each one of these boxes is equivalent to 3.8. Now we could have left this as a fraction as well. We could have called that 3 4/5. But I think in this instance, it's a little bit easier just to use a decimal. 3 4/5. It's equivalent to 3.8. So now our last step, if I know each box is worth 3.8, I have to take away 2 to figure out what the x is. In other words, 2 plus what gives me 3.8? And that answer is 3.8 minus 2 would give me 1.8. Now another way you can look at this, if you wanted to draw it this way, you don't have to do this the second time, but I'm going to write it this way. We could have 5 x plus 2 equals 19. And I could use my distributive property. 5 times x is 5x. 5 times 2 is 10. And that equals 19. In this scenario, we have to solve it a little bit differently. We have to first get rid of our 10, subtract 10 from each side. And then we bring down our 5x equals 19 minus 10 is 9. And now we divide by 5. And we get our 1 4/5, which is equivalent to 1.8. So there's 2 ways you can do it. There's actually less steps if you leave it in groups and divide first. But that's taking a tape diagram, writing an equation, and solving the 2-step equation.